Well, welcome back to another NetPlay seminar. I'm very excited this week to introduce Will Thompson. Will is a PhD student at the University of Vermont at the Complex Systems Institute now, isn't it?
Yes, big
That's very
change.
cool. Yeah. So I know Will from some time there at UVM, and we're really excited to hear you talk about your work on learning opinion dynamics kernels. So whenever you're ready, Will, take it away.
Okay. Well, thank you so much for having me. Without further ado, let me share these slides. Come on, there we go. All right. All right. And okay. Can you all see that? Okay. Yeah, so thank you all so much for having me, Eric. I really appreciate the opportunity to be here and talk about my work, and not just my work, but the work of my collaborators as well, on learnable models of asynchronous and also synchronous opinion dynamics. Okay, so this is done as part of, it began as part of AMS Mathematical Research Community Summer Program about 2 years ago. It's an awesome program. You spend a week in Buffalo, New York, working on some sort of math related project. And this was our project, and it has since blossomed. So, to begin with, here are my collaborators. The PIs are Heather Brooks and Phil Chadro. And then we have Vicky Modisette and Tom Gebhardt and Alex Weidman and Moi Tan and Len Hune. All great people, all doing excellent work. So I'm presenting this, but this is the product of lots and lots of people working on it. Um, Okay, so one of the big problems with modeling dynamics in social systems and modeling dynamics in general is there are two kind of very different types of models one might use. Um, One are models where you can really get down to the nitty-gritty of the causal mechanisms, where I can specify here's my guy, he follows a set of rules, he interacts with other guys, and these are sort of within the frame of agent-based models, right? The problem with these is that they're very hard to actually fit to data. On the other side, you have things like regressions, right? So these are really good at fitting to data, at discovering patterns and trends within data, but they don't really give you much causal insight into what mechanisms may be generating these trends. So the idea is, can we find a model which both has this underlying agent-based model causal structure, but can also be fit to data? And in our case, we're going to be thinking about how opinions spread on social networks. I talk to you about something, your opinion changes. How can we take a causal agent-based model for something like opinion dynamics and apply it to the context of learning and inference? So we're going to think of a very simple model where we have a set of agents or individuals, and each of those have an opinion, right? So an opinion is some sort of real valued quantity. We could imagine it being bounded between -1 and 1 or 0 and 1. So our lab, our PIs are both proud French Canadians. So we can think about how squeaky could poutine cheese be on a scale of -1 being not squeaky at all to 1 being very squeaky. Then each agent is a node in a network and has some sort of value, right, of squeakiness. So super simple, probably too reductive model of how opinions might work, but we have to start somewhere. Then the actual model is going to be very simple. So we're going to pick one agent at a time. An agent is going to pick a neighbor, and it's going to update its opinion in some way. So we have a discrete time model, and my new opinion at time t plus one is going to be some function of my old opinion, and then a change, and this change is going to be stochastic. So we're going to have noise in the model, which makes the process of inference much more difficult, right? And how do you actually figure out what that change is going to be? Well, the way this works is we randomly choose a node j from your neighborhood. And then I look at its opinion and I look at my opinion, and then I choose an update as some deterministic function of the distance between my opinion and their opinion. So we call this function the kernel, right? And that tells you how much do I listen to someone else. And then we're also going to scale it. We're going to assume it's scaled by the distance. So all things being equal, if someone is further away from me, I'm going to move in their direction a certain amount. And then how much I move is determined by the kernel. And we also have some sort of measure of variance. How noisy is our model? This kind of model encompasses a wide array of models in the literature on opinion dynamics. So the simplest possible model would just be I pick a neighbor at random and I move in their direction proportional to some amount, right? That would be called like a de Groot model, and that's essentially just graph diffusion. The next simplest model would be a bounded confidence kernel. And in this model, I look at my neighbors. And if they're within some sort of socially acceptable window of opinions, I listen to them with 100%. And if they're outside of that window, then I don't care at all about what they have to say, right? So these models are called bounded confidence models because I have some sort of bound on who I actually care about. So this particular one, which is just the simplest possible, the Higglesman-Krauss bounded confidence kernel, is parameterized by a single real number, phi, which determines the width of that range of opinions I listen to. There are other modifications. So another smooth version of this would be the sigmoidal bounded confidence kernel. So whereas before we had a single phi, which determines the width of the kernel, now we have a secondary parameter, which determines how steep it is. So as phi 2 goes to infinity, we end up with the sort of infinitely steep bounded confidence kernel. But as we relax that, we end up with sort of these smooth, sort of Gaussian looking kernels, right? Um, we also have the simplified de Groot kernel. And here I look at a neighbor, and then my update is just, or my kernel is going to be a convex combination of my opinion and my neighbor's opinion. And then that little interpolation parameter of how much do I listen to myself and how much do I listen to my neighbor, we're calling that phi, right? So in all of these models, we either have one or two parameters. But you can see these models are very different. In the case of the simplified de Groot, we don't even really have a notion of sort of opinion space, right? We're just sort of interpolating between the two opinions. So many, many models within the world of opinion dynamics can be fit into a frame like this. Okay, so the goal is given some observations about opinion dynamics over time. This is going to be a time series for each node in our network. And we also assume that we know the structure of the social contact network, which is a big assumption. And an avenue of future work would be how can we sort of jointly infer both the dynamical model as well as the network structure at the same time. But we're assuming we know that social contact network, that we don't know who each individual listens to at each time step. The goal is going to be to infer the parameters of our model. So right now I presented only parametric models. We could also imagine performing this non-parametrically. I will address that later. Okay, so we're going to use an expectation maximization algorithm, which is super classic stats thing where we have some sort of likelihood function, right, which tells us the probability of a given data set given our generative model. And in this case, our generative model is what I laid out, right? It's this sort of discrete model of opinion dynamics. Well, generally, we want to find for a given set of data the set of parameters which maximize the likelihood of that model, right? That's great if we sort of observe all the data. But in our case, we have latent unobserved information. And that is at time step t, agent X picked one of its neighbors to listen to, but we don't know which one, right? So we have to sort of work around this unobserved information in our model. So generally, expectation maximization comes in two steps. The first step, we take our likelihood function and we calculate an expectation value of that over all possible assignments of our latent parameter. So here, in our case, that is an expectation value over all the possible neighbors a given agent could have listened to. And then this gives us sort of a provisional value. And then given this, we optimize our parameters with respect to it. Um, to get a new guess for our parameters, and we repeat this process until convergence. So note the first kernel I showed you, the bounded confidence kernel, is not a smooth kernel, right? It's this discrete step function. So we're going to have to treat this optimization step both in the case of smooth kernels, where we use gradient descent, and in the case of non-differentiable kernels, where we have to use some method of gradient-free optimization. Okay, I won't go into the details of the expectation maximization algorithm, but suffice it to say it works well. Okay, so here we have some of our results. And you can see On the left, we have the bounded confidence kernel. We can see that empirically we reconstruct the shape of the kernel very well. So we see the ground truth is in blue, and the inferred kernel is in red, and we have a very small deviation. You can see again for the Higglesman-Krauss bounded confidence kernel, we do. So I think the biggest takeaway from this is that yes, we are able to reconstruct the parameters of our model very well in most cases. But that's not, we can dig deeper, right? One of the problems is, all right, so this is just basically a measure of the distance between the two kernels. So if we have our ground truth and inferred kernel, what is the area between those two? It gives us some notion of the error within the parameter space of our kernels. You can see the total variation distance here is in red. Now we can sort of ask, well, we can do very well for a particular example within a particular range, but throughout the range of possible parameters, how well do we do? Are there places where we run into issues with the inferability of different kernels? And you can see that here. So here, phi 1 controls the width of the kernel. So this is for the sigmoidal bounded confidence kernel. Phi 1 controls the width. So when phi 1 is low, we have a very narrow kernel. And when phi 1 is wide, we have a very wide kernel. Now, phi 2 controls the steepness. So when phi 2 is very shallow, or when it's very low, we have a very sort of like shallow uh, Gaussian look like distribution. And as phi 2 increases, what we see is the kernel gets more sharply and sharply peaked. So we can see that when we have um, a very shallow kernel, when you have a lot of information about sort of different opinion values, look very different in the kernel, we do very well. But as we get to the more and more peaked region, as our kernel looks sharper and sharper, our error goes up, which makes sense, right? Because at some point, if someone is, you know, zero point 0.5 away from me or zero point 0.6, but my kernel is only zero point 0.3 wide, I can't really tell the difference, right? There's some sort of lack of identifiability between those two scenarios. Um, you can see here, right? When we have this nice smooth kernel, it works well. But when we start to have these sharper kernels, it breaks down. So one of the questions is this bounded confidence model is a classic model from the literature on opinion dynamics and is motivated by evidence from the social sciences. So the question is um, how well does one of these discrete bounded confidence models really model social interactions versus a relaxed sigmoidal version, um, which we can do much better when we can infer. In real data, are we really seeing these very sharp boundaries regarding people's um, uh, opinions? Here you can see that Higglesman-Krauss bounded confidence kernel. So this is the discrete analog for the sigmoidal bounded confidence. You can see, again, as we increase the width of the kernel, we do worse and worse, which makes sense. Because if I have a very wide kernel, I'm listening to basically everyone. But if I have a very narrow kernel, I'm only listening to people within a very small range of me. So it becomes harder to infer that value when I'm listening to everyone. I have much more information when I pick people very carefully to listen to. Um, you can see the DeGroote kernel doesn't necessarily follow the same pattern. The total variation distance is very low across the board. And we don't see a huge difference in that sort of parameter for our interpolation. So we're able to recover the kernel well, regardless of the value for the DeGroote kernel. Okay, so far, what we've done is we've assumed that we know the functional form, right? So we're saying we're going to assume that the dynamics were generated by a bounded confidence kernel, or they were generated by a DeGroote kernel. But in real data, of course, we don't actually know what model best fits the dynamics. So one of the coolest things would be able to look at data and try to discover non-parametrically what is the shape of the kernel. And this would allow us to do some amount of hypothesis testing, right, between different parametric kernels or sort of discovery, right? Like when we look at data and we try to find the most explanatory kernel, um, does it look like any of these models in opinion dynamics, or does it totally different? So we can think of a multilayer perceptron as just this small, very simple neural network as a universal function approximator. So in our case, our MLP will take in two inputs, which is the opinion of node I and the opinion of node J, and it produces one output. And as the number of hidden units within our network increases, we can approximate functions more and more accurately. So in this case, our M step of our expectation maximization algorithm simply becomes just backpropagation across the weights of our network. So here, we don't make the assumption, like we were doing before, that kernels are translationally invariant. So before, we assumed that how much I listen to you is simply a function of the distance between my opinion and your opinion, right? But what my opinion is, or what your opinion is, does not matter, right? So we could both be super far squeaky or super far non-squeaky, and that kernel looks the same. The absolute values don't matter, only the difference. But in the case of our MLP, in the most general framework, we don't have to make that assumption, right? We can just say, well, the kernel is some generic function of two inputs, xi and xj, which can depend, right? So in this case, we have the ground truth. So this is data generated using a sigmoidal bounded confidence kernel. You can see that on the left. And you can see the shape of that kernel, right? The nice little Gaussian distribution, sort of as diagonal cross sections of the heat map. And the MLP, you can see, gives us a fairly good approximation of the results. Um, so uh, right now, we're thinking about these modeling choices. When we have a non-parametric kernel, does it make sense to assume the input is translationally invariant? Does it make sense to assume that dynamics could play out differently for different absolute values of the two opinion nodes, which obviously is a much larger and richer space of kernels. But there's not a huge amount in the literature around opinion dynamics on non-translationally invariant kernels. Okay, so this is what we've done so far. We've developed a framework to infer interactions, and we've shown that we can do well in both the case of parametric kernels, and we can perform the same non-parametrically. And we've been able to characterize the ranges of identifiability. So I think the next step is thinking about how this could actually be applied to data, which is much, much harder because people don't have easily quantifiable, in text data, online, social media. It's very difficult to try to find any measure of opinion as some real valued number. Um, and then it's hard to try to quantify, well, what is the social interactions between people? And people have done work using Reddit data to infer sort of similar models for opinion dynamics. Um, but I think right now, this is one of the biggest challenges we're facing. And also finding a kind of opinion that changes at a regular basis, where my opinion on, abortion or something like that, that's probably pretty fixed. I'm not going to change a lot based on interactions with other people. So are there domains where my opinion is something I don't hold quite as closely, right? Where I could read a post online and my opinion can change in a measurable amount. So where are things where people don't care so much about their opinions, but they advertise their opinions quite frequently? Because I may not advertise my opinion on an issue at a regular interval on social media. So we're looking for ideally some case where people both change their opinion frequently online and advertise their opinion. So one of the domains we're thinking about are prediction markets, which are these sort of online stock market type things where instead of a stock for a company, you have an event, right? So will the Nasdaq be above, X on September 12th? Or will Tim Cook release the new iPhone with X, right? Um, and people will bet on these, predictions. And you can see over time how the predictions change, and they become very good, sort of like aggregators of wisdom of the crowds. So in this case, people have an opinion. It's something which does change on a regular basis. And people advertise and quantify their opinion by betting on one outcome or the other and then they will change their bets as their information changes. And there is a network structure. People interact in the comment sections of these of these prediction markets. Um, so in many ways, it's an ideal case, but um, there's also big sort of exogenous influences, right? My opinion on what Apple is going to do next quarter depends a lot on not just on my interactions within the network of other people, but also on news coming from outside. So are there things like like prediction markets that don't rely so much on exogenous information, that rely more on information being transmitted between users within a social network? Yeah, so that's what we're thinking about, and I would love to hear people's thoughts on possible applications and data sets and so forth. Um, yeah. So, Eric, I don't know how this works exactly, how the two parts of the talk are split up. If we have a discussion now on the content of this.
Yeah. Why don't we give? Thanks so much, Will. I mean, that's a really great talk. And yeah, why don't we take some opportunity to ask questions about this before we move on to the next section? Does anyone have questions for Will?
Mm, I might have a couple, but like I will start with one. So, like, thank you very much. Like, the talk is like quite inspiring for me, and I like it so much. But like, my question is like, seeing opinion dynamics in a way that you want to like find out what are the parameters. Like, it is also like some topic that has been discussed before. Like, people have done, I don't know, like Bayesian inference of like parameters, or like I don't know, like the using like a physics informed machine learning in order to estimate like what are the functions behind, like how your method is superior comparing to the methods that is previously like investigated, like why are those like not really good and yours is like much better. So like this is my question.
That's a great question. I think it's different in several ways. So there's been work before. There's some work which is, yeah, using like graph machine learning, these kinds of approaches. Those are great for prediction, right? But what they lack is a interpretable model. So our whole model is based around inferring parameters for kernels. So the idea is the results, even if they're non-parametric, even if they're generated using a neural network, we have this sort of function space representation of the kernel that we learn from our neural network, which is very interpretable, right? It tells us information about how much I changed my opinion based on your opinion, in a way which, using purely graph machine learning type techniques will not do. There's also been other work. I'm not familiar with applying Bayesian inference, but there's been other work applying, other frequentist statistical inference techniques. Often those models are more limited in the kinds of opinion dynamics models. They usually will pick a certain model and then use inference to fit that particular model to data. I think this paper makes this observation, which is not, I don't think, a super common framing within opinion dynamics, that many, many models can be seen as specifying a given kernel. So it fits in this happy medium between it is both interpretable and specific enough to sort of be useful, but also it is general enough and flexible enough that we can fit a wide class of models to the same data. Yeah, that's a great question.
Thank you. If there was no other questions, I would like to ask one more, but like I will let others like to ask their questions as well.
I have a bunch, but go for it. Yes. Yeah, go for it.
So, like you were talking about like trying to use the social media data in order to understand like how the opinion dynamic works. There are like two concerns that I might have. Like one is like that all these like things that you said about like the shares and like the stocks and this kind of stuff is like mostly like a story that is written before, and people are just like using propaganda techniques to make sure that the market is going under influence. This is like one important aspect to think about. And another one is that you should make sure that the network is stable, meaning that the time scale of the change of a network should be much longer than the opinion that you have. Because people, in other way, like there are other opinion dynamics that says people, if they see that they have like a very high opinion difference, they might unfollow each other, or they have like new connections. So like instead of changing their own opinion, they change their network, and like that makes like a huge like difference in terms of like what model to use and what model not to use. So what do you have like to make sure that like this is not the case?
That's a really good question. I hadn't considered that. Yeah, I mean, I think there's lots of really awesome work on like the dynamics of like adaptive networks. And they have these like very counterintuitive, strange outcomes. We're not factoring that in. Um, yeah, that's a really good question. That might be a domain, a kind of a question of application. Like, where are domains where, again, people don't hold their opinions so tightly, right? If I see someone and they say something really odious about, the president or whatever, like I might really want to unfollow them. But if we're talking about something that is not so close to sort of my identity, I'm probably not going to unfollow someone because of an opinion. So it's really finding a data set which fits into that happy middle ground where people have opinions, but they're not so strong that they're going to sever links in the network. Yeah, and it's been a hard question of,
Yeah,
finding that.
yeah, true, true. Thank you so much. I think it's all okay. Thank you.
Fantastic question. Thank you so much.
Can I just follow up on that?
Yes.
Definitely, yeah.
Oh yeah, so yeah, like I think that's definitely something to consider for sure, like what kind of data and what kind of like opinions we're talking about here. And as you both said, I agree with Will and Yas both. Like maybe the case that you like talked about, the prediction markers or any kind of like other like visible cross type of thing might be a better application than like an opinion about something more radical or more controversial or some opinion that I actually like hold close to me, and then I will advocate it like to the people around me and all of that, and I will probably like most likely won't change it in the I don't know in a like short period of time, let's say at least. So you wouldn't be able to actually perceive those changes like online for sure, like but even in real life if you were to able to observe people. So that's the tricky part. I definitely agree. And I'm not sure, like again, like you said, with prediction markets and other like kind of like those crowdsourcing platforms, and like people when people come up with forecasts about different issues, like there are also geopolitical markets that people like guess stuff about what's happening in the world, but those are things like that do not directly reflect people's own opinion, but like mostly influenced by what's happening around the world, like mostly tied to politics, economy, and all of that. So I'm also having like a hard time finding a good data source to actually use for this kind of like applications.
Mm.
I feel like that does not exist, maybe like like but like the one that kind of checks out all the criteria that we would wish to
Mm.
have.
Yeah, no, I think it's a really hard question. And I think it's sort of, yeah. I mean, there's very interesting applications, but they're sort of stymied by this problem, right? That actual dynamics are so complicated of people's opinions. Yeah.
Yeah, and
I mean,
also
maybe adding on
I
to
was sorry, yeah, can I just say
no,
one
no,
more
go
thing?
ahead.
It's kind of
Yes,
like
definitely.
shifting it a bit more, but I was also so yeah, my master's thesis was also like about like opinion dynamics, and I know I'm quite familiar with the literature that you mentioned. But there are also some stuff, especially on the like the more like political polarization part of the things and stuff related to political like opinions sometimes, yeah, as like either through like link breakage, or sometimes people even like shift their opinion to the more extremes after like interacting with somebody who is far distant to them. So there are also like models that kind of like try to capture that as a like second dynamic, like as opposed to us getting closer, we can actually like go farther apart
Yeah, so
at
actually,
times.
I didn't have it in the presentation, but one of the kernels we're
Yeah,
looking at is a repulsive kernel, um,
yeah,
where I'm attracted to people if they within a narrow range, and then
yeah.
outside of that, if I am actually repulsed by them, and then it sort of goes asymptotically to zero, and that creates very very strange dynamics, because people can kind of ping off if they
Yeah.
people they really hate. Um, yeah, and that also makes the inference much more difficult because all of a sudden you have a non-convex loss landscape, right? There are many local minima. But it seems like there's lots and lots of cases where those repulsive dynamics are really important. Um, yeah, I think that's really interesting.
Yeah, I definitely agree. Like, especially in the like social science theory, I think that is something kind of like grounded. I mean, we do see it happening in the real life for sure. So that's definitely something to consider. I mean, not for every opinions, like I wouldn't really be like bothered by something like I don't know, somebody says about something random. And if it's like too different from my opinion, yeah, I wouldn't really bother. Like that wouldn't make me more extreme.
Right.
But about things like more closer to like yeah like political issues or like I don't know like around those lines, that's definitely gonna have some impact.
Hmm. So I'm curious. I mean, I'm not as familiar with the social science aspect of opinions. I mean, yeah, like this connection between repulsive behavior and adaptive networks, right? These sort of extreme reactions to saying a negative opinion. Um, those are not the case in general, right? They sort of depend on how seriously I hold an opinion. And there almost
Hmm.
be like a big separation between the kinds of dynamics I expect to see when I really care about an opinion and the dynamics I expect to see when I may not care about it so much. And I'm not sure if that's something which has been investigated from the qualitative
Yeah, I
perspective.
don't think there's like a clear separation between, oh yeah, these are the things that we care more about, and then we would do this kind of like repulsive like behaviors, and these are the other stuff that I mean, there's no like distinction between those for sure. But especially in the cognitive domain, I think like cognitive dissonance, like just
Mhm.
because you don't want to actually like hear about all those like quite different opinions, you would like break those ties, you would, I don't know, like stop looking at those sources of information and stuff like that. And also on the becoming more extreme part, I think there's this like theory on like social judgment, I think it was called. I mean, we can talk about it later if you're curious. Yeah.
I'd love to hear about
Yeah.
it. Thank you.
Well, great. I would. I'm torn between asking one more question and moving on to the next section. Um, but I think in the interest of time, Will, why don't we go ahead and maybe go on to the discussion section? Um, I think you had a great abstract about choosing your niche. So do you want to just sort of introduce that a little bit and then we
Yeah.
can talk about it?
I mean, I think this is kind of related to some of the things we've been discussing in this period of like, I don't know exactly where you all sit within the world of network science, but often there's sort of a split between people who come to network science as domain experts, using networks as a tool to study a particular domain, and people who come into network science as a domain in and of itself, right? Who are interested in methodology and understanding of networks abstractly. And I think a lot of research straddles that divide. Um, and I mean, I think this is a perfect example where, there's part of it which is purely a methodological, um, exercise. We're developing a new inference algorithm for certain kinds of, network coupled dynamics. But on the other hand, we're purporting to model social systems. Um, and what I've found is, in general, people in network science, I mean, myself included, especially myself, I don't have a very firm understanding of the domain I purport to be modeling. Um, and I think this is true of a lot of people in network science, where part of the benefit of working in a field like this, in an interdisciplinary field, is you can work on many different projects from biology and social sciences, and which is wonderful. But also, it raises this question: to what extent should you, especially in a world which is, moving more and more to generalists, moving more and more to interdisciplinary research, should you find a niche? And as a young researcher, like I've been struggling with this, and I would love to hear other people's thoughts. Um, should you devote yourself to one subject? Uh, is it irresponsible to purport to model social systems without having a deep knowledge of sociology? Is it irresponsible to model ecosystems without having a deep knowledge of ecology? And can I rely purely on collaborators as domain experts and seeing yourself as um, the methods person or the generalist? Um, to me, that seems like a tenuous position. If I'm doing this work, but I'm relying on other people to be the person to like check to make sure I'm not blowing smoke. It seems like you ought to have some obligation to really understand the field, but that also comes at a huge cost of time. You can't choose multiple fields, right? You have to really sort of specialize. And I'm just curious what you guys have felt. How have you navigated this? And to what extent do you feel a push towards one or the other?
Oh, it's a great question. I struggle with that literally all the time. Like I think I feel myself as a methods person who is interested in a few different domains. One of them is like urban science and science of cities, and you go in and you try to work with mobility data, and requires a lot of just domain level expertise about how the data is collected in something like this, or actual social systems themselves. Like I think opinion dynamics is like the quintessential example of where physicists are like, oh yeah, like consider a one-dimensional space and blah 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 math, and then the psychology literature, the social psych literature, like the political science literature, they all have ideas on this, and um, it's tricky. What do people think?
I mean, what I can say is like I didn't want to like make my hands dirty when wanted to like collaborate in some projects. For example, like I wanted to do a project like on science of science, and now I'm doing like a project on like animal behavior. There are two different kind of things. Like they are not even real near to each other. Like, but I'm doing like temporal networks, and temporal networks is like can apply to both of these settings. And then for both of these projects, I started with saying like, oh my God, like I'm gonna just like get the data, apply the same methodology that I know. I'm so interested in to see like how this method that I know is going to behave on this data, and then just like infer some like results out of it and interpret them later. But then it comes to the point that then you say, wow, I really need to understand what is this data about. Like, I need to understand what is this domain about. For example, like I had this project about like the science of science, and we wanted to talk about like how is the temporal network of like I don't know like a funding and migration in this scientists are changing throughout the Arab Spring, and I didn't know like what are the Arab Spring itself. Like I had to really go deep and understand it itself. So like you cannot really sit in the methods person chair and say, I'm going to do all this and then we can interpret it together, because you have to be aware of like what you're doing actually.
Right.
And that makes a huge difference between you as a method person not knowing anything, or like that person like applying network science without knowing anything about network science. So anyway, I think you should just deep dive and try to learn something about. And that's pretty energy and time consuming, which is totally understandable for me. So
But I also think like that doesn't really require you to like present yourself as a domain expert or to
no.
become the domain expert in any of those domains. You just have to devote some time and like read some stuff and try to understand, try to make sense of what is already out there. So not be like neglective and just ignoring what is happening in the social science domain or like whatever topic that you are studying or applying your methods on. But I think at this point, that's probably like something all of us kind of struggle with. I mean, I studied engineering, industrial engineering, and I was like made to be like work in the industry pretty much. And then I did my master's in there as well. But I was like, okay, you know what? I'm more interested in how like people do stuff together. So how groups of people interact with each other, how do they behave in certain under certain circumstances. So then I switched to social sciences, but that was a big shift. And I do still feel like I'm an imposter, even here, like even if I'm doing a PhD in whatever social sciences department, like because like all the people around me still have like more deeper knowledge than me. They do know, they've been studying this for so long. So I will never probably get to the level that they have, like even
Mhm.
after getting my PhD in communication, computational social science, whatever. So it's okay. And we should definitely rely on like, I think the worst thing we can do would be just like, yeah, neglecting the other side of knowledge that exists, and just like, okay, you know what? I have this fancy method that I want to apply to this system, and then just boom, like all of a sudden our problems are solved. But yeah, I think definitely like trying to like devote some more time to understand what's happening, but also collaboration with people who actually know what's happening. That's definitely key. I would say, yeah, that those are my 2 cents, definitely.
Yeah, I
Uh,
totally agree. No, sorry. Was anyone else talking? No?
all you.
Okay, can I? Okay, so hi, William. I'm sorry I missed the talk part. I will uh, watch it on YouTube, but it's a really like interesting discussion topic, and I wanted to add something more than what Yas and Gosha said. It's also like I don't feel like the like domain expert, so the sociologist part of the a project would make the effort to become like expert in the methodological part. So I don't feel that it's also like fair that we want to reach like the domain expert level, but it's also true that we cannot like ignore totally that part. But it's something that I'm experiencing now because I started with like a more methodological kind of research, and now I'm getting more and more into the like the computational social science part, and I'm finding it difficult also to like search for things. I mean, in my field, I know how to like navigate the literature, and but like if I have it's like I mean I find it difficult to also like starting knowing more about what I'm focusing on the different field. I don't know if it's something that also you struggle with, or it's just my problem because I hate doing literature review. But yeah, so that's my 2 cents.
Yeah, I found going off that. I have another collaboration with two linguists, and I think there's this really weird thing where they know a lot about the literature of like linguistics and pragmatics, and then you kind of come together, and you're trying to figure out one, like how could the nouns of linguistics and pragmatics, how can they be translated into a modeling framework, right? And it's often the language they use, the concepts they use, are very foreign to someone who comes from a background which is not in linguistics or pragmatics. And I think, yeah, like when you start looking at literature, like it's just so hard to even orient yourself or do it well. It's easy to read a paper and think, oh, I understand it, right? But not understand the nuances and the subtleties. And I think there's a way in which like fields can be very alien to each other, even if they appear to be superficially similar, or even if you appear to be superficially understanding something. Like being able to judge, do I really get this? Do I get the implications? Do I get the historical context of these ideas? Is a much, much harder task. And then formulating these ideas within the language of network science or modeling or inference, doing it well is very difficult. Yeah, and I think that literature review process of do I know what to search for? Do I even know what they mean? Is hard.
Mm-mm.
So this conversation is so much reminding me of Samuel's from 2 weeks ago. Samuel gave the last talk at the NetPlace seminar, and he was saying that what you really need to have a successful interdisciplinary collaboration isn't just somebody from this domain and like somebody like all the different pieces together. You really need to have a shared understanding, right? That the person who's the domain expert has to at least know how to talk about networks and complex systems or something like this. And then vice versa. The person who is the methods person still has to know at least something about the domain. And I think his point was largely that the most successful collaborations, there's the most overlap, or maybe there's some sort of Pareto optimality where like you want to ideally everybody knows as much as possible, and these circles of overlap are as big as possible. But yeah, so kind of similar to what we talked about 2 weeks ago. Yeah.
So it makes sense that like interdisciplinary research is like getting like more and more like the case, and then like these issues are rising, and then we have this recurring issue like from many people. It's pretty interesting.
Right. Anyone else have thoughts on how to be an interdisciplinary researcher, which is a famously easy task?
No, but like something to say is like I wanted to say the last word, like just because your title was like choosing a niche or not, like what do you think is your like niche that you have chosen, or like you are in the way like choosing it?
Right. I mean, I think if I do choose a niche, it is in the world of opinion dynamics and complex contagions, right? Modeling how ideas and memes, whatever, spread on social networks. Um, and I think it's a interesting and fruitful area. But one of the other issues is, I think a lot of other people have the same experience that your collaborators, the people you're with in wherever you are generally also coming from the methodological side, right? Are coming from the hard sciences, the physical sciences, um, or computer science. And there's not that many people, there's like maybe like the token sociologist, right? But I think to Eric's point, right? Like I think that's a really interesting idea that good interdisciplinary collaboration requires, um, everyone around you, not just a single domain expert to have that knowledge, to have an overlap. Um, and I guess part of the problem, I don't know, like if you do commit yourself to a niche, right, on choosing a path, how do you build up that expertise when most of us are sitting in departments which are not surrounded by sociologists, which are not surrounded by social scientists or biologists? I think it's much, much harder to like gain that sort of like tacit understanding and, of a field.
Yeah, but like I think like mostly like opinion dynamics, like they are like mostly like raised and like understood by the socio physics people, like people like they were having like a background and education in physics, and they were like introduced to complex system and also like socio-physics, and then they were like building on top of that, understanding like the tipping points, understanding the phase transitions, understanding like how it could be. So I think in the sense of like the methodology point of view, it's still interesting understanding the chaos, understanding like this kind of like what is so called like emergent behavior, and building the theory on top of that. So like in my opinion, which I'm nobody, like I would like to say like opinion dynamics, it's a very nice niche that like the methodology part itself is pretty rich itself. That you can go as deep as possible in the physics part, in the like the computer science part, in the mathematics part, and then just like don't touch the data at all as well. So like it's your choice choosing even the sets even. Yeah, maybe no data set at all as can also work. So
Well, I think that's like a really great place to end. I'll end with a quote from Chris Moore, which is just everyone should think about everything all the time. We should just uh, time and knowledge constraints be damned. We should just do it all. Um, Will, do you have any closing remarks maybe before we wrap up for the day?
Well, thank you all for, attending the talk and for this amazing feedback. And this has been a really interesting discussion. Yeah, so thank you all. And thank you, Eric, so much for facilitating this.
Great. Well, yeah, thanks so much, Will, for being here. Really fascinating talk and discussion. So thanks, everyone, and look forward to the next one. I think this is the last one of the year, right?
yeah,
That's right. So see everybody in the fall.
bye.
Bye.